Hey, sweetheart. Well, today we'll get back to science. We're going to look at some of the evidence from physics as we consider these two competing hypotheses. One, the universe and everything in it was formed by strictly natural causes. Or two, the universe and everything in it was created by an intelligent source, which of course I refer to as God. Now, just a quick reminder to keep these questions front and center. Does the evidence appear to be designed, or could it just be an accident? And what are the chances that this could have happened by accident? Okay, let's jump in. Scientists have learned that everything in our universe, whether living or inanimate, from stars in the heavens to stalagmites in a cave, everything functions according to what we now call the laws of nature. The very curious thing is that these laws are perfectly arranged to support complex life. Well, keep that thought in mind because we'll come back to it shortly. But first, let's think about the beginning. In the letter on cosmology, we learned that up until 60 or 80 years ago, every scientist thought the universe was eternal. Since then, the questions have been the same. Where did everything come from? And why is there something rather than nothing? Physicists are pretty sure they figured out what happened. Let's watch.
A split second, the Big Bang, and the whole universe was born.
In the blink of an eye, literally, so much can happen that it would blow your mind.
How did we get here? And what is the universe made of?
The secret of creation, the secret of everything is locked in that first second.
Technology stands on the brink of revealing what happened in the most important second of all time. In the beginning, there is nothing, no matter, no energy, not even empty space, because space itself doesn't exist. No time passes, because there's no such thing as time. From nowhere appears a fireball smaller than an atom. 10 trillion times hotter than the core of the sun. Everything that will become the universe explodes from a point millions of times smaller than a pinprick. Time begins. In 1 second, the blueprint for the entire cosmos is written. How it happened is the biggest mystery. In this first tiny beat of Planck time, something happens that shapes the next 13.7 billion years. Out of the fireball, the 4 fundamental forces of nature form. Those forces underpin everything around us. Gravity is the reason stars and planets form. It rules the moon and tides and keeps us on the ground. Electromagnetism lights our cities, connects our phones, and runs our computers. And the 2 nuclear forces, strong and weak, bind the particles that make up our bodies and power the furnace of our sun. We're here because in the first second after the Big Bang, the 4 forces are created. WMAP tracks the Earth as it orbits the sun and scans the temperature of the whole sky. It generates detailed temperature maps like this one, and it reveals something remarkable. The blue and red patches on this map of the entire sky are tiny ripples in temperature.
The little blue regions represent regions that are a few tens of thousands of degrees colder. Red regions are a little bit hotter, so you're seeing tiny variations in temperature across the sky.
WMAP looks back over 13 billion years. As the universe evolves, these tiny ripples develop into clusters of particles that get bigger and bigger under the force of gravity, becoming just dense enough to trigger stars and galaxies to form.
I mean, it really was what I think we all dream of when we go into science. Looking at things that no one's looked at before, learning really exciting things about fundamental questions. Questions like, what's the universe made of? What happened in its first moments?
This is a map of how the universe looked in the first second after the Big Bang. The template for today's vast cosmos.
When the picture of the cosmic microwave background radiation first came out, the press said, the face of God. Well, let's be real. It's not the face of God. What it really is a baby picture of the infant universe. So the discovery of the cosmic microwave background radiation ranks as one of the greatest discoveries in all of science.
Only a fraction of a second after the Big Bang, and the destiny of the universe is already mapped out. The sun burns because of forces forged more than 13 billion years ago. The stars and planets form from the way the universe rapidly expands. Science can trace everything we see today back to the first second of creation.
We were expecting to find a gas when we slammed gold nuclei into each other. So the shock was, it wasn't a gas at all. We found that it's more like a liquid. So this came quite a shock, because now when we begin to simulate the early universe, we have to get rid of this mental picture of a gas of subatomic particles. Now we know it's more like a liquid, literally like a soup.
When matter first appears in the universe, the quarks are so dense and so energized that the entire universe is like a liquid. The universe went from a glowing ball of energy to quark soup in less than a blink of an eye. The liquid universe is hot, dense, and violent, flooded with tiny particles in constant vigorous interaction. As our cosmic clock reaches a millionth of a second, the universe continues to expand and cool. It grows from the size of a baseball to the size of our solar system. Matter has materialized from pure energy. Without matter, none of us would be here. Our cosmic clock takes its final beat of Planck time. The universe is 1 full second old. It's about 1,000 times the size of our solar system, and flooded with particles of matter, the raw material of everything around us. The universe is cool enough for the sea of quarks to bunch in threes, forming protons and neutrons. In the saga of the universe, this first chapter set the course of history.
The first second of the universe was an incredibly exciting and important time. During that first second, all the matter in the universe was made. All of the neutrons and protons were made. All the key components to make the universe today, we think, were already in place. And then everything just evolved forward.
In the next few minutes, the universe cools enough for protons and neutrons to form the first atomic nucleus. 300,000 years later appears the first atom. In hundreds of millions of years, matter clumps to form the first stars. And in 1 billion years, galaxies like the Milky Way. More than 9 billion years after the Big Bang, Earth is born. One Big Bang, one single second. the genesis of everything.
By the time you've got to the end of 1 second, the rest of cosmic history is prescribed, including, ultimately, the future of the universe.
It's amazing to me that physicists have figured out what happened in that first second after creation. It's even more amazing that those seemingly chaotic events eventually produced our Earth. Watching this video reminds me of the one we looked at earlier of the big construction project. Since it's a short video, let's watch it again. Well, these two videos are similar in this respect. Both start out with a blank slate and wind up with an amazing home for humans. And while we don't know who designed the arena, no one would doubt that someone did. And there's no doubt that the universe and our planet are perfectly designed for complex life. Well, let's see what that means exactly.
From galaxies and stars, down to atoms and subatomic particles, the very structure of our universe is determined by these numbers. These are the fundamental constants and quantities of the universe. Scientists have come to the shocking realization that each of these numbers has been carefully dialed to an astonishingly precise value, a value that falls within an exceedingly narrow, life-permitting range. If any one of these numbers were altered by even a hair's breadth, no physical, interactive life of any kind could exist anywhere. There'd be no stars, no life, no planets, no chemistry. Consider gravity, for example. The force of gravity is determined by the gravitational constant. If this constant varied by just 1 in 10 to the 60th parts, none of us would exist. To understand how exceedingly narrow this life-permitting range is, imagine a dial divided into 10 to the 60th increments. To get a handle on how many tiny points on the dial this is, compare it to the number of cells in your body, or the number of seconds that have ticked by since time began. If the gravitational constant had been out of tune by just one of these infinitesimally small increments, the universe would either have expanded and thinned out so rapidly that no stars could form and life couldn't exist, or it would have collapsed back on itself with the same result: no stars, no planets, and no life. Or consider the expansion rate of the universe. This is driven by the cosmological constant. A change in its value by a mere 1 part in 10 to the 120th parts would cause the universe to expand too rapidly or too slowly. In either case, the universe would again be life prohibiting. Or another example of fine-tuning. If the mass and energy of the early universe were not evenly distributed to an incomprehensible precision of 1 part in 10 to the 10 to the 123rd, the universe would be hostile to life of any kind. The fact is, our universe permits physical, interactive life only because these, and many other numbers, have been independently and exquisitely balanced on a razor's edge. Wherever physicists look, they see examples of fine-tuning. The remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. If anyone claims not to be surprised by the special features that the universe has, he's hiding his head in the sand. These special features are surprising and unlikely. What is the best explanation for this astounding phenomenon? There are 3 live options. The fine-tuning of the universe is due to either physical necessity, chance, or design. Which of these options is the most plausible? According to this alternative, the universe must be life-permitting. The precise values of these constants and quantities could not be otherwise. But is this plausible? Is a life-prohibiting universe impossible? Far from it. It's not only possible, it's far more likely than a life-permitting universe. The constants and quantities are not determined by the laws of nature. There's no reason or evidence to suggest that fine-tuning is necessary. How about chance? Did we just get really, 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 really lucky? No. The probabilities involved are so ridiculously remote as to put the fine-tuning well beyond the reach of chance. So, in an effort to keep this option alive, some have gone beyond empirical science and opted for a more speculative approach, known as the multiverse. They imagine a universe generator that cranks out such a vast number of universes that, odds are, life-permitting universes will eventually pop out. However, there's no scientific evidence for the existence of this multiverse. It cannot be detected, observed, measured, or proved. And the universe generator itself would require an enormous amount of fine-tuning. Furthermore, small patches of order are far more probable than big ones. So the most probable observable universe would be a small one, inhabited by a single, simple observer. But what we actually observe is the very thing that we should least expect: a vast, spectacularly complex, highly ordered universe, inhabited by billions of other observers. So even if the multiverse existed, which is a moot point, it wouldn't do anything to explain the fine-tuning. Given the implausibility of physical necessity or chance, the best explanation for why the universe is fine-tuned for life may very well be it was designed that way. A common-sense interpretation of the facts suggests that a super-intellect monkeyed with physics, and that there are no blind forces worth speaking about in nature. The numbers one calculates from the facts seem to me so overwhelming as to put this conclusion almost beyond question. There is for me powerful evidence that there is something going on behind it all. It seems as though somebody has fine-tuned nature's numbers to make the universe. The impression of design is overwhelming.
The perfection of this fine-tuning is amazing and really almost unbelievable. If any one of those dials was changed just a little bit, no life would be possible. These are pictures of Leonard Susskind and David Deutsch. These two men are well-known physicists. They're going to talk about this conundrum.
Leonard, what is it about the fine-tuning of this universe that causes such energy, such controversy among scientists, philosophers, theologians? Everyone today is talking about fine-tuning. Why?
Well, it seems, and we don't completely understand why, that the laws of physics, laws of cosmology, laws of how the universe evolved, seem to be very special. Of course they're special. Everybody would expect them to be special, but they're special in a way that's unexpected. They seem to be special in the way that is just very, very conducive to our own existence. The laws of physics could have been very different. You could imagine a world that didn't have electrons in it. There's nothing wrong with that in the basic theory of the mathematical theory of physics. You could just throw away the electron. What would happen if you threw away the electron?
No chemistry.
No atoms, no chemistry, no biology, no people to ask the question.
Right.
We just wouldn't be here to ask the question. You could change the rules in other ways. You could make gravity strong. Why is gravity so much weaker than the other forces? Well, we don't really know, but here's what we do know. If it were just even a little bit stronger, stars would burn out too quickly. They wouldn't live long enough for life to evolve. Instead of stars, instead of galaxies, we'd have black holes. We can't live in a black hole. I mean, science fiction, maybe you can live in a black hole, but we can't really. Most likely the universe would expand and contract too rapidly. And so everything seems to be almost on a knife edge, that if you were to change the rules of physics, the laws of physics, even a little bit, the world as we know it wouldn't exist.
The laws of physics seem incredible in that they are perceptible to us. We can manipulate them. We can use them for predictions. What does that begin to tell us in terms of their fundamental nature? And how can we begin to look at the laws of physics and see what the nature of reality is?
It's certainly the case, and I think this is now uncontroversial, that if the laws of physics were very slightly different in almost any way, there could be no life in the universe, no complex chemistry, and no thinking people, and therefore no one who knows the laws of nature. So they are somehow almost infinitely special in that they allow themselves to be, as you said, not just known but also used, and that they were used before humans even existed to create life and then for the human species to evolve. Now, that has been for several decades an unsolved problem at the foundations of physics. Why that is so, called the fine-tuning problem. And it began in a serious way. People began to investigate this in the 1970s. The physicist Brandon Carter, who was investigating the evolution of stars, found that if the charge on the electron had been only a few % different, either larger or smaller, then there would be no complex chemistry and no opportunity for life to evolve.
Well, these guys are among the top scientists in their field. They can go on for hours about the what, the where, and the when, but they have no answers if you ask how or why. It just is what it is. Perfect for humans. But why is it perfect? Well, on that question you get nothing. I want to introduce you now to Robert Jastrow. He was an American astronomer and a planetary physicist. He was a NASA scientist and also a popular author. He was the first chairman of NASA's Lunar Exploration Committee, which established the scientific goals for exploration of the Moon during the Apollo lunar landings. At the same time, he was also the chief of the theoretical division at NASA.
Just as I can't believe that there was a creator, I can't believe that this all happened by chance. which implies there was a creator. So you see, I'm in a completely hopeless bind, and I've stayed there. Again, I find it hard to believe that this is all a matter of atoms and molecules. And so I try to fit into my concept of the world the conclusion that there is a larger force of some kind, which we can call God, or you could call it whatever. But I can't accept that. I'm what's called a materialist in philosophy. I believe in, that doesn't mean I like Cadillacs and big cars. My students always used to think that. It means that I believe the world consists entirely of material substances. And when you specify those substances, the atoms and molecules, and the laws by which they interact, you've done it all. There isn't anything more to be said or inserted into your model of the universe. And that's what my science tells me, and I've been a scientist all my life. But I find it unsatisfactory. In fact, it makes me uneasy. I feel I'm missing something, but it will not. I will not find out what I'm missing within my lifetime. If you reverse the motion, the outward motions of the galaxies, and go backward in time, they come closer and closer together, and you reach a point finally where they're nearly infinite in density and temperature, and farther than that you can't go. So there's a beginning. There's a point in time from which it all started. And that's a remarkable thing because it has a very strong theological flavor to it. And that intrigued me because I am an agnostic. And if there was a beginning, a moment of creation in the universe, then there was a creator. And a creator is not compatible with agnosticism. And I found that message so interesting that I felt a strong compulsion to share it with others. And so that's why I wrote that book.
Now let me give just one example of how finely tuned our environment is for life. Everything has weight. Even air has weight. These are the atomic weights of 3 different gases. Methane is 16, ammonia is 17, water vapor is 18. The first 2 of these are deadly poison. Now gravity as it is allows ammonia and methane to float off into the atmosphere. If gravity were just a teeny tiny bit stronger, ammonia would pool along the Earth's surface and we would all die. Water vapor is essential to life and maintaining the Earth's water cycle. Gravity holds the water vapor close to Earth. But if gravity was just a teeny tiny bit weaker, water vapor, just like methane and ammonia, would float off into space, and eventually the planet would be dry and barren without any life. Well, gravity is only one of the 30-plus physical constants that make up the laws of nature. Each one of them is perfectly balanced for complex life. What are the chances, do you think, that this perfect balance of 30-plus variables is just an accident? It certainly appears to me that a super engineer has designed our system with complex life in mind. Before I close, I'd like you to hear what some of our well-known and best astronomers and physicists have said about the universe and our Earth. This is Arno Penzias, and he says, "Astronomy leads us to a unique event, a universe which was created out of nothing and delicately balanced to provide exactly the conditions required to support life. In the absence of an absurdly improbable accident, the observations of modern science seem to suggest an underlying, one might say, supernatural plan." Well, these men were and are some of the brightest minds in astronomy and physics. They recognize that the evidence from the physical world points toward intelligent design. Well, sweetheart, we're off to a good start. My next letter will be on chemistry, and I'll get that to you as soon as I can. It was really great to see you over Christmas. Now that you're back in school, continue to work hard on your studies, and we'll hope to see you again soon. Remember always, I love you.